Good morning, everyone. Can you guys hear me well?
Yes.
Yes.
Very nice. I will anyway add like a headset so I can hear you guys well also. Let's wait like 5 minutes for your friends to join. I know it's like 9:30 in Innopolis and not many people wake up that early. So let's give them some time, guys, okay?
Some people in the waiting room, they asked to let them in.
Thanks a lot, Lev. Just to confirm, it's like Karim Kochekov, that's it?
Shamil Festiv also.
Oh, still don't see them. It takes some time for them to like show up to my list here, and definitely takes some time for them to be let in. So let's wait. Yeah, I think there is like a problem with my camera. Can you guys like see anything or?
We can see the lecture slides.
Okay, good. Yeah, I think I'll just turn off my camera. And yep, joining. Yeah, we'll start in like 1 minute. After 1 minute, guys, I will not be able to check who are like the students that are joining. So like if somebody is like speaking in your Telegram channels or like your friend is saying they cannot join the Zoom, please like interrupt me and ask me to add them, okay? How many students do we have like in this between bachelors of data science and the bachelors of robotics?
We should have like 40 something, like 45.
45. So there are like 15 students who did not show up to the lecture. Está floja?
Maybe you just remove the waiting room so we join us later.
That's a very good, like, what is it called? Thing, proposition, but that's the thing. I have no idea how to do so.
There's something with the security on the bottom of the screen.
Nice. Yep.
There should be something about the waiting room.
Perfect. You have disabled the waiting room. Thanks a lot. Like you get like a lot of bonus points for this. Da-da-da. Oh, there are 37, no, 36 students in total in this course.
Excuse me, is it okay if we join together in a single room, but we come from a single Zoom?
Yeah, of course, definitely. Yeah, there's no problem. Just like a small heads up, the only reason that you should always attend the, what is it called? The lectures is that we will be having a quiz in the start of every lecture for like starting next week. So even if you join through the same Zoom, like for the next lectures, try to at least have your laptop opened, right? So that when we start the quiz, you can quickly start answering. And being in the same room with other students, that's gonna be a bit bad. No cheating, guys. Huh? Like the quizzes are gonna be very easy, so you don't need to cheat anyway.
But what are quizzes, like typical quizzes in the Moodle or in
Yes,
the Zoom?
very typical
Moodle?
quizzes in Moodle, yep.
But why you cannot convene single room? Like
I didn't get the question. So what I was saying is like you can be in the same room, no problem, but always make sure you have your laptop with you. Okay.
Okay.
Yeah, like if you can answer using the phone, I'm not sure if you can, but feel free to do so if you have like the if you cannot use your laptop for that. Anyway, forgetting about the quizzes for now. So welcome, guys. I am Bakush Imad. So I will be your lecturer for the course of Introduction to Computer Vision. As you may know, this course was primarily taught by Professor Fahim for the last 4 years, maybe or so. And yeah, so Professor Fahim left the Innopolis University like a couple of weeks ago and went to the UK. And Professor Khan and well, the other education department members couldn't find a replacement, so they asked me to like give you guys this course, since I was already teaching the master's guys on advanced computer vision. This course is going to be a little bit of an introduction to the Advanced Computer Vision course, which is an elective. We will be covering things such as basic computer vision tasks, such as like extracting features from images and stuff like that. And of course, we will go to a bit more advanced concepts such as object detection and image segmentation, right? Just so I would like lay up a little bit of expectations. So I was not really told about the schedule of the course, so I'm not really, so we're still not prepared for this course yet. Both me and your teaching assistant, who just came back to Innopolis from Syria. But we will be doing our best, especially in the first week. It's going to be a bit hectic. But as of like the second week, things will go back to normal and you would not feel a difference. Again, another thing. Yes, the content of the course, or at least the first half part of the course, will be on like the basics of computer vision, right? So very easy stuff, just some mathematical equations and things that I personally would perceive as useless, since you would never really use them in like research or in industry, but you might find them useful for like future labs. And the second half will be on more applicative things. So we'll be speaking, as I said, about convolutional neural networks and some of the improvements of CNNs, such as like RCNNs and stuff. And these things are definitely very useful for you, both for research and for industry. The aim of this course is definitely to prepare you guys, since you are fourth-year students, to. Can you share screen? Yeah, of course. I want first to like have a small conversation with you guys. Here you go. So yeah, so the goal of this course is definitely to give you a small introduction to what's gonna come next in the next few years of your career, whether you're going for a master's degree or you're going for like an industrial career path. So I think let's start using slides since they're here, and I'll start with first like a small presentation of who I am, like what did I do, what are my research interests, what's like my background, and just so you guys would be more comfortable asking me questions about different topics and not asking me questions about special topics, right? So like a small introduction. I've done my bachelor's in computer science with a focus on data science in Algeria. And then I did my master's in data science in Innopolis, where I met most of you guys. And then I'm now currently doing my PhD in artificial intelligence in Sorbonne University, right? This is a picture of Sorbonne University. It's a very beautiful university, but like just fame. Yeah, it's not really that much different from Innopolis University, although it's like ranked in the top 30 universities. Like the level of the students is way worse than the level of the students of Innopolis. And definitely the level of education is nothing better than Innopolis. My work experience, so I've worked in like a couple of French companies in Algeria while I was in Algeria. I did some mobile development, web development, and then I started working as just pure data science. So not something related to computer vision or anything, but mainly just data science and processing tabular data using sklearn and stuff like things that you have already seen in machine learning course with Professor Khan, I assume. Then I moved to Russia and started working with the Innopolis research labs. One of them is the machine learning and knowledge representation lab. I think now it's called something artificial intelligence lab with Professor Khan. And that's where I did my master's thesis. And yeah, I've been working with a couple of students there. So I've supervised a couple of students for their bachelor's thesis and I think one also for their master's thesis. It was pretty nice. We were managed to publish a couple of papers with Professor Khan, and from there I moved to the artificial intelligence center. It's again in Innopolis University, but it's not under Professor Khan. It's under Professor Ramil Kulia. Definitely was an interesting experience. We worked on medical imaging, and yeah, we worked on like medical imaging and a little bit of domain adaptation. Also, while doing so I tried to both maintain like what's it called, a research career path and a industrial career path at the same time, you can say so. So I started working with a company in Russia. It's called Provectus. So it's a very simple, like ordinary company that's based on inside Kiev, Odessa, Kazan, Innopolis, and San Francisco. So they have lots of like offices everywhere. And their job is basically to perform artificial intelligence tasks for other companies, right? So the other companies outsource AI tasks for them. With Provectus, I've been working primarily on object detection tasks for different clients around the world. So one of our main products for European companies were like worker safety product. So basically we were trying to detect helmets or people who are not wearing helmets inside of construction sites. And I think like the same part of the same project, they did some other stuff for mask detection and like some medical detection, like gloves and stuff like that. And currently I'm working with Pepsi, so the drink company, right? So I'm not working with Pepsi, I'm working with PepsiCo. So it's like the mother company of Pepsi. And what we do is we have a lot of brands. So Pepsi apparently like owns Lay's, owns many other products that you can see in supermarkets. And as you can guess, there are definitely a lot of data that Pepsi can extract from Facebook, Twitter, Instagram, ads, stuff like Super Bowl ads, game ads, all of these data and basically sales in different stores. So definitely there is a lot of data. So our job is to model all of that data across, of course, primarily the US and across European Union and Canada. So it's definitely a very interesting job. My background is quite heavily focused on computer vision, but I also worked with data science like in general. My main research interests are computer vision. So yeah, anything that is image classification, or like improving image classification, anything related to object detection. That's what I've been working on for the past few years. And yeah, these are like my two focus areas. The second part is domain adaptation. Just going back to computer vision. Yeah, anything also related to medical imaging or anything related to historical images. So that's also something that I'm working on, if that's of course something that interests you. Domain adaptation. So I assume if you took the course of Professor Khan, he still gives like the final week about domain adaptation. Is that correct?
It was a year ago.
Yeah, it was 1 year ago where you guys studied about domain adaptation. That's yeah. So basically domain adaptation is a very simple field, which is very highly related to, transfer learning. The goal is to use a external source dataset, or let's call it an original dataset, that contains more images, but that is closely related to the dataset that you are working with, and kind of extract enough knowledge from this source dataset to improve the performances of your models on that target data set, right? So for example, if you're working with traffic images for like your Tesla, you can improve the results of these models trained on these traffic images from a Tesla by using some images from GTA, right? So it's a very similar concept. You're still driving. There are still other vehicles, there are civilians. So there are definitely some concepts that you can learn from GTA and transfer them to real life images taken from a Tesla. The final part of my research interests are knowledge graphs. So I worked a lot on knowledge graphs. So knowledge graphs are just a way to store data in a manner that is focused on the relationship between the data. So you can imagine these nodes as being objects, and they're kind of related to each other in a way that creates a graph. Let's say this is like the Mona Lisa painting. It was made by Leonardo da Vinci. That's his name? Yeah. It was made by Da Vinci, who was living in, for example, Italy. And now the Mona Lisa is stored in Paris. So this is the kind of data that we work with. And the goal of using such data set is to allow basically computer vision models to understand a bit deeper than just like a class. So for example, when he looks at a picture of a mother holding her newborn child, it's not just a human and human. So he would be able to understand that this is a mother and this is a newborn child, and he would like make an assumption that this person is the mother of this person. So all of this can be extracted from just one single image of a mother with her child, right? So this is the goal of using knowledge graphs in combination with computer vision models. If you guys would like to contact me, you can always use Telegram. I respond pretty fast unless I don't. And you can always use like my my email. I never really check email, so try to contact me through Telegram. It's easier. I will update this link. So this link was for the old course materials for the old course Telegram channel. Just a small question. Are you guys all on the Telegram channel that Karam has made? Is there somebody who didn't hear about this Telegram channel? It's called ICV course. Oh, there are 34 members. There are 30 of you. It's safe to assume everybody's there. Okay, nice. The grading criteria, right? So definitely the most important part will be your midterm, final exam, and the quizzes. So the quizzes will be, we will have around five quizzes. Let's say 3% for each quiz, totaling 15%. The midterms, we will have like a midterm that is like paper-based and a lab exam. Usually the lab exam is pretty easy, so it's free 10 points for you guys. And then there is a final exam, same thing, paper-based and lab exam, which is 10%. Both midterm and final exam will be graded by your TA. So because I have like, yeah, I usually give good grades to everybody. So now it's going to change and your TA is going to handle that. Is this like a suiting format for you guys, or do you have any other ideas? Like you don't like the lab exams or something like that?
At least now we have no idea in which form it will like. What does it mean, lab exam? Like we will need to train the whole model in an hour, for example. What?
Not really, not really. Yeah, usually I'll just give you a very simple task. Basically, I give you the whole running code, and you guys just change, for example, the data set used for this model, right? So for example, I give you the code to train like a CNN. Sorry, I give you the code to train a CNN on MNIST, and then I ask you to train the same neural network, but for example, on USPS or SEHN. So these are other data sets, very similar to MNIST, but they have like different properties.
Okay, sounds good. But what about languages and frameworks? Because all of us have different experience, like different frameworks, and it will be unfair to give us different, for example, TensorFlow, while some of us maybe half using PyTorch in their work and research and things like this.
That's amazing. I think the slide right next to this one, not this one, I will start by getting to know you guys and understanding your background, and that's definitely going to influence the content of this course. Okay, so right after we finish from the grading criteria and the outline, I will have to ask 5 students from every group to basically introduce themselves, introduce their backgrounds, the things that they already know, just so I can get to know what kind of students are we working with, okay? Sadly, since I'm not part of the Innopolis University team, I don't really know what courses are you guys taking, and it will be a bit challenging for me to adjust basically the content of this course for you guys. For the master's students, it was easy since the program was still the same, so I already knew what they know. But for you guys, I would need for your feedback basically to understand what courses have you guys taken, what frameworks are you familiar with, do you guys know how to do like basic mobile programming or like web development and stuff like that, okay? Moving on from the exams and quizzes, which are, as I said, the main part of the course evaluation criteria. The second part is mini projects or homeworks, right? So we're going to have 3 homeworks in total starting next week. Again, my homeworks are always very easy. I try to like make the homework content as easy as possible. What you guys will need to do is usually just change 1 or 2 lines of code and run the code. It will work directly. The goal of these homeworks is not to basically stress you guys or take more of your time, but to make sure that you can play with code that is already written for you guys, okay? So the evaluation of whether you guys can write code and do all of that stuff will come next. So basically in your final project. The final project is supposed to be something that kind of prepares you for your next steps, right? So for example, if you want to be like a teacher in the university, you can give us a small lecture about some concept that is related to computer vision. That can pass as your final project. Or you can do some open source contribution. For example, you found a cool open source project and you go to some issues in that project in their GitHub link and fix that issue and merge your pull request. Or you develop your own product. So in my master's program, I had many students who are already like creating their own startup. So if that's the case for you guys also, your product itself can be your final project if this product is related to computer vision. And of course, to those of you who are working already on their thesis, and I'm sure there are many, you can easily just show us, like present to us your paper that you have published if it's in the field of computer vision, right? There will be like 2 parts. The first part is a mid-evaluation, which is like 5%. The mid-evaluation will not, probably will be, okay, maybe, not sure. So you might need to present the project like twice. So basically the mid-evaluation will have a presentation, sorry. And the final evaluation will also have a presentation. The mid evaluation will be presented in 5 minutes. The final evaluation will be presented in 10 minutes per every group. Do you guys have any questions about the grading criteria?
Everything is cool.
Everything is cool. That's nice. I think another very important question would be how are the what they call the letters A, B, C, and D. Since your basically scholarships and money is dependent on the grade of these courses, for now I'm gonna keep everything the same. So basically, the A starts at 90%, B starts at 75, and C starts at 60, and D starts at 0. But after the course finishes, I will spend some time trying to get as many students to get an A as possible, get as many students to get a B as possible, and basically get as many students to get a C as possible. So the threshold for getting an A definitely will decrease. It will not increase. Same thing for B and for C. For now, we are keeping the default values, but once the course finishes, I will take a look at your grades, see how much effort are you guys putting in, and definitely reward you accordingly. The goal is not to take points from you guys or to give you extra points, but in your case, since it's money related, I will try my best to keep everybody happy about it, right? The content of the course, right? So as I said, the first half of the course will be the same thing as what Professor Fahim did. So most of the slides that you will see are slides of Professor Fahim that he left for us. And probably, yeah, most of the not the homeworks, but most of the lab material also will be the same thing that Professor Fahim and his TAs presented to us, left to us. So the first part would be on image processing. We will be speaking about like the basics of computer vision, like from before computers were invented, right? Second part would be feature extraction. So we will be speaking about stuff such as how to extract hot features. We will speak about the Viola-Jones algorithm for face detection and stuff like that. I'm trying to get like some basic video processing into this one because it's pretty important for you guys to check that algorithm that I have in mind, but we will see. So I will do my best to include some video processing techniques here, which are actually still very much used in both industry and research. Now, the second part of the course would be on basic machine learning. So CNNs, we will speak about what CNNs are. We will speak about interpretability in CNNs. And then we will speak about GANs, right? So generative adversarial neural networks. The final part will be on object detection. So basically we have recurrent or region-based convolutional neural networks, or RCNNs. And we have YOLO, which is you only look once, right? So these are the two main families of object detectors. RCNNs are kind of like the big architecture that was providing very good results, but and YOLO is like the architecture that is fastest and doesn't always good results, but now their performances are kind of like approaching to each other since their final versions are kind of almost the same. So the goal again of this course is to give you an idea of what the next steps in your life will be, both by making you build a hands-on project of your choice. So depending on the career that you would like to go through, you will choose your own project. And definitely there's going to be a lot of theoretical knowledge in there. many people will say, like, if I'm going to the industry, I'm not going to need a lot of theoretical knowledge. So it's basically just how much programming can you do and how many projects can you build, right? Even if you don't understand the architecture of RCNN, you can just like call it with one line and say model.predict and use it, right? That's what matters. Sadly, that's not really the case. So in our field, even if you go to the industry, passing the interviews will require a lot of theoretical knowledge. So like saying from experience, while moving from Provectus to Pepsi, I was the only person from my company to be chosen, and only because I still had like some of the theoretical knowledge that they asked. Their interviews were quite harsh and contained a lot of mathematics and linear algebra basics, and just basically explained to me the function, like the step-by-steps of every single algorithm for interpretability, and then explained to me like the architecture of RCNN in detail and what makes it, for example, slower than YOLO. All of these theoretical questions are actually very useful. So try to like retain as much as possible and like revise on it, okay? So theoretical knowledge is also very important, whether you're going for a research career or you're going for an industrial career. So now is the part where we get to know each other. So I spoke a lot about myself. I told you guys about my background. So now I would like to get to know you guys. So please, I would like to have 10 students from data science who just tell me about their background, things that I've already worked with, if they know some frameworks, if they're good with Python programming, if they are good with PyTorch, TensorFlow, all of these things. Please go ahead. And 5 students from robotics team.
Okay, I can go.
Go ahead. Yep.
So I'm the data science second
Nice.
group. So I worked with Keras in the third year with Professor Khan and did some research with him, and worked with PyTorch in my internships in first and third year in basically computer vision. You were helping me in one of them.
Nice.
And basically, like I also know like the other basic stuff like scikit-learn and stuff like that, because we were using them in IDAO. Like I entered IDAO and we were the top 30. And basically, yeah, like I'm also interested in computer vision. Like I'm planning to make it my main focus for learning in the future.
That's pretty nice. That's very nice. Very interesting profile indeed. So I'm sure that you have like very good capabilities in PyTorch. We will be building on that. So we'll definitely be using some sklearn, some OpenCV, and hopefully switching to more Pythonic environments. But definitely in the end of the course, we will be using stuff such as Darknet and CUDA programming. But definitely, yes, PyTorch will always be there. So there are a lot of object detection models which are still written in PyTorch. They're a bit slower, but we will be using these too. So having a PyTorch background is very useful. Those who know TensorFlow can just go and die, right? It's useless. So I see that Amina has opened her mic. Please go ahead if you want to. No, she didn't open her mic. Okay. Who else wants to present? Maybe someone else? Maxime?
I can present.
Go ahead.
Okay, I'm Daniel. I'm from robotics. My main research in path planning for self-driving cars. So I have worked previously with TensorFlow mainly. I know I passed several courses on computer vision by myself, like I know OpenCV and stuff, PCL. Yeah, basically that's it.
That's very nice, very impressive. So I know that you are a very good student. And I remember you were a straight A student, very surprising. But that's very nice that you are in this course. Interesting background working with like robotics and so path planning using, I think, reinforcement learning or something like that. That's pretty nice. So you're definitely going to need a little bit of computer vision. Anyone else? So for example, Ahmed Hamdan, definitely would like to get your background, bro. And we have yeah, Hani, definitely a very interesting background. Go ahead, guys.
Yes, I'm here. Hello, everyone. My name is Ahmed, I suppose. Like most of you know me. From my background, actually, I don't have like, I cannot say that I have any background in computer vision. I only have background in machine learning because we had this course previously with Professor Khan. And because my work is in my thesis is not very related to computer vision, it's more towards control and so on. So yeah, I suppose that's what I can say about myself.
That's pretty nice. So the majority of the students in this course are not expected to have any computer vision background. That's why it's called an introduction to computer vision. So it's nice to know that. So basically, you represent the majority of the students on this course. So that's nice.
Okay, great.
Do you have some experience with PyTorch? TensorFlow?
I have with PyTorch a little.
Nice, nice. Anyone else? Alfia, Alexander, Anna, Artyom? Anyone? Go ahead.
So hello, I'm not Alfia Artyomana, but my name is Alva. And I have some experience with computer vision. I have some internships and some pet projects, but I decided to switch not to from computer visions to data analysis and NLP. And I have some projects with NLP and analyzing biological data. My thesis is not about machine learning at all, but about analyzing networks and biological data. Also, I'm fond of interpretability and security of machine learning. So I hope we will touch these topics in relevance to CNNs. That's it, I believe.
Thanks a lot. Thanks a lot.
And yes. Also, I have experience with Python programming, obviously, and my main framework is PyTorch. So for deep learning, for machine learning is sklearn,
nice.
And that stuff that we use.
Nice. That's very nice. That's a very interesting profile. So definitely, I did not expect that somebody who's not primarily focused on introduction. Like I thought everybody should be focused primarily on computer vision. I'm disappointed, but that's good. That's good. So it's always very nice to have like a different background than the others. It's yeah, it's nice to have like at least a good, solid background in a computer vision, at least for your future career. So it's definitely going to help you open more doors. And why not do some combination between your field of work and computer vision? So it's a very interesting career choice. Interpretability will definitely be a part of this course, but I don't think we can go through it in a lot of detail. So basically just one lecture on it. If you are interested in interpretability, we have kind of like 3 lectures on it on the course of advanced computer vision. So if you are interested or already in the advanced course, you will have a lot more content on interpretability there, based both for tabular data and of course for computer vision, right? Anyone else would like to just like a final presentation of somebody who is taking this course? No need to have like a very extraordinary profile. I just want to understand what the average person knows in this class.
Hi, I'm Anna. I just don't want you to think that everybody's working on their thesis by now and has a lot of experience with computer vision and stuff, because I don't, and I guess some people also don't have it.
Nice.
I only had a course on introduction to machine learning, and I maybe read or watched some videos about computer vision, but don't really know much. So we were looking forward to this course.
Thanks a lot, Anna. That's very nice. Thank you so much for stepping up and telling me that. Definitely gonna expect you to be more kind of the voice of the students who are definitely new to the field and would like to learn a bit more. So if you feel like we need to take a small break, or we need to take things a bit lower or slower, please always step up and tell me to like repeat something or go slower on something, okay? So thanks a lot, guys. I just got to know some of you. So just to wrap up, there are some students with very impressive backgrounds who are already working on who have been working on their thesis for 2 years already. And there are some of you who are completely new and as expected are starting to work on their thesis in this semester. Both students are always very welcome, and definitely there's going to be a lot of things to learn from both sides. I have different expectations for every student, of course. So for those students who are pretty advanced, I would expect them to have a better final project, right? So something that they have put a lot of work on. And for the newer students, I would like to see an improvement in their knowledge, right? So let's say they had no idea how to do object detection tasks. I would like to see that by the end of this course, they are very familiar with building such models quite easily and quite quickly. So there's definitely this shift in expectations, but I'm sure both of you will enjoy the course, or I hope so. So thanks a lot, guys. Just to give you a small heads up, majority of the course will be like the start of the course will be on Python and some of the lower level libraries, such as like, sklearn and OpenCV, NumPy, stuff like that. The second part will definitely be with either PyTorch or TensorFlow, as you guys wish. So I will try to like make I will not the one in charge of the labs, but I will try to ask the teaching assistants, who's Karam, to provide to you the lab, same content, both in TensorFlow and in PyTorch, and you guys can choose. Very similar structure now. And yeah, for your final project, you can use anything you want. Definitely for object detection, where we might step away a little bit from Python environments. But you are, of course, allowed to use anything you guys want. You can start thinking about your final projects as of now. So now that you guys already know what are the what is the content of this course, so you can start working on things such as interpretability or object detection. Usually these are the two main things that students like to work on. But now that we have the introductions set, let me just ask you a simple question. Do you guys want another Telegram group for the lecture and a separate Telegram group for the, what are they called? For the labs, or just one is already too much?
One.
Yeah, I agree also. I think one is already too much. So if anybody has any questions, please go ahead and ask. I will pull up the first lecture and we will start with basics of computer vision.
I have a question about the final project.
Yes, of course, go ahead.
So you said like for papers, we can only show you the papers which are already published, or like which are like submitted or not published yet. We can show that also.
A very good question. So if you are working already on a paper, you can present anything you have already. So as long as it is your own paper, yeah, feel free to present anything that is published or anything that you are working on and trying to publish, okay?
Yeah.
I also have some question about final project. Could
Yes,
I?
of course, yeah.
First one, are we allowed to work, for example, on project in groups, for example?
Yes.
2 people?
Yes, of course. So you can work in groups of, what are they called? 1
Pairs?
person, 2 or 3 people, okay? So
Okay.
feel free to add your friends or the people that you are more comfortable working with, right?
Yes, and my second question is, are we allowed to implement something about this course? For example, training some image transferring, style transferring for GAN, like something artistic, but still with computer vision applied. Please.
I didn't get the first part of the question. Can you repeat it, please?
Could we implement something not related directly to your course, but connected with computer visions? For example, training
Yeah, of course, yeah.
or image transferring. Okay.
Definitely, yeah, of course. So, like, you're not gonna be training like what is it called? An image classifier directly and tell me this is my final project. Definitely, you're gonna be combining computer vision with something else, preferably like interpretability, maybe object detection since it's a little bit new. And for example, for those who are interested in, as you said, something artistic, go ahead and use stuff such as GANs and style transfer, anything that you're working on or interests you the most, right?
Okay, thank you.
Nice. How do we share? Let us share the screen. So now we will start the content of our first lecture. Honestly, there is 0 information gain in this lecture. So you're not going to be learning anything interesting or anything new here. We're going to be speaking about like the basics of computer vision. And like maybe in the end, we will present like some formulas that might interest you guys. But other than that, complete, nothing very interesting here. Right, let's get through it together. So first, we will be speaking about the computer vision basics. We'll speak about what are the applications of computer vision, and we will speak a little bit about the human vision system. Then we will speak about some image concepts such as sensing, acquisition, sampling, quantization. Then we will switch to speaking about color spaces. So I'm sure everybody knows RGB. We will speak about other color spaces and how can we convert from one space to another. Yeah, there are some very ugly formulas here, but you can easily just program them in NumPy and very quickly have the thing done. So let's start with the computer vision basics. So the goal is basically, again, to give computers a higher level understanding of digital and of digital images and videos. So this is like the definition that you will get from Wikipedia. What we will be seeing is definitely an introduction, very basic stuff. So what is an image? How are they represented and stuff like that? And then we will speak about the applications of computer vision. And then we will go and check how the human vision system works. This is quite important so that you guys understand why did we make the choices that we made in representing images, right? So a very basic introduction. So computer vision was inspired by the capabilities of humans, since our vision system has been developed over a couple of years now. So apparently human beings have existed for a really long time. And before that, we were fishes. So we were also seeing stuff in the sea. So we have like a very developed vision system. And now they changed it into a computer vision system, starting from like the 1960s and the 1970s. And in like the first half of this course, we will be working on the technologies of the 60s and the 70s. Definition of computer vision. So computer vision is the automatic analysis of images or videos by computers in order to gain understanding of the world. So here is like a simple example. this is an image of a horse in like some desert. And we feed this image to a ResNet model. So it's a ResNet 50. And basically this is the distribution of the classes or the predicted classes by ResNet 50, right? So here we can see that the model is saying that this image is an image of an Arabian camel. So we can easily see that this is not a camel, this is a horse. But since the model was heavily influenced by the environment or the surroundings of the horse, he classified it as an Arabian camel. So this is the problem here. And this is, let's say, the problem, and again, the good thing. So as we can see here, the model was able to not only see what the object of interest is, but also what its surroundings are, and understand basically that this is something in the desert. This is something that could be related to Arabian animals. And he went ahead and made the decision that this is an Arabian camel. So although it's a wrong decision, but it's a very well-informed wrong decision, right? So I'm proud that the model said this wrong decision. Yeah, so this is the goal of computer vision, basically to give the model an ability to extract features or extract information from images, even though it might lead to wrong predictions, but still the model was able to understand different things from the image, right? So he is extracting some very higher level information about these images. So again, the goal of computer vision is to understand like the story behind a picture, right? So remember in the previous image, we didn't just see a horse and say it's a horse. We looked at the story of this image. So this is an animal that is inside a desert. This is an animal that is inside some like old sand-based castle. We're trying to interpret what is like the relationship between the objects inside the image. And all of that is done inside one model. So this is again the idea or the goal of these models, which is to understand the story behind every picture. One way, one person would say that the goal is to understand what are the objects and where are they and what are the relationships between them. So these are like the three main questions that you would like to answer using computer vision. So what are the objects? Where are they inside the image? And how are they related to each other? So here we can see like two basic images. So we see houses. We see that this is which time this is, let's say this is the spring. There are lots of flowers here. So it's, yeah, it's something that's not in the Arabian deserts. So definitely we can extract a lot of information from these images as human beings. And this is the capabilities that we would like to give to any computer vision system. Here, for example, we can say that this is kind of the nighttime, not the morning. So you can see that this is like a canal or some sort of sea. One person would say probably on this side, there is also a, what is it called? A beach, not a beach, what is it called? That's like, well, a side of the river. So a person, a human being can say this is not a sea, but more like this is a river that is crossing in the city. Another person might say that this is a picture taken by a person on a ship. So this is in fact a sea, and he is just sitting on a ship instead of sitting on a river. And another person would say that this is, again, the same thing as a ship, not a ship, this is a sea picture and taken, for example, from a drone, right? So all of this information, again, can be extracted from images, and the goal is to give these computer vision models the ability to extract all of this from the image they see. So a very interesting application that now we can see a lot all around the US, but it's also making its way to, for example, Russia and Europe. So it's Amazon Go. So let's take a look at what Amazon Go is. By the way, can you guys see the video or not? Tell me, huh?
Yes, yes.
Can you hear the video?
No.
Yeah, that makes sense. So I'm gonna share this link with you guys. And everybody just like try to run it locally. Here we go.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store?
So you can see that this was fully doable as of the 2017. So like this was like 4 years ago, right? So the technology to empower such stores was already existent in 2017. Definitely by now, this is like a piece of cake. Like you guys can easily build a system that does this. Definitely not with the same performances as Amazon, but at least the first part where you guys can check this person took this object. This is definitely something easily doable by any computer vision student nowadays. Of course, the accuracy of it will depend on how much data they have, but the quality, or at least the pipeline itself, can be built by anyone nowadays. So again, what Amazon Go is, so it's some sort of like an app plus a system that allows you to go to any of these Amazon Go stores and pick whatever you want. Anytime you pick something, it will add it to your cart. And if you return it, it will basically remove it. And when you walk out of the store, it's going to charge you for the items that you took with you. So the system is pretty simple, based on object detection, object tracking, and a lot of facial recognition, of course. So a small introduction to what computer vision is, right? So computer vision, as we said, is about understanding images. Images can be like a lot of stuff, right? So we can have like black and white, grayscale, colors, or sorry, multispectral images. So we can have snapshots or video sequences. We can have something taken from a static camera or from a drone. We can have something of stationary or dynamic scene. We can like taken from a calibrated or an uncalibrated camera. So calibration is like just fixing the parameters of the camera. We might be speaking about these things a little bit later on. But for those who are into photography, you will know that, for example, when you take an image, there are like those shutters and stuff like that. And you can play with the parameters in order to improve the quality of your image. Usually for people who have like a smartphone, you do this task by just like pressing on the screen on the face of your friend, and voila, his face looks more clear and the background is kind of blurred a little bit, right? What computer vision aims to do is basically to extract as many information, as much story from these images as possible for many purposes, such as inspection, analysis, and control. So for example, our friend who is working on detecting the path or predicting the best path for like self-driving cars. So he's working on control. Those who are working on analysis would like to understand what's happening in an image. Let's say, for example, something like Amazon Go. And those who are working with inspection, just to make sure that, for example, you have like traffic lines and making sure that everything is going well. Why to study computer vision now? So one very good reason is like we have a lot of data right now. And since our, as we said, as the, what is it called? Theory of evolution says, so our vision system is like the most advanced system that we use to perceive the world. So it's been with us for a really long time. Unlike, for example, speaking and hearing or writing. So these are kind of recent compared to vision. And this is why we like to process images more than audio, for example, or more than text. And now we have tons of images everywhere. So you have like on Instagram, Flickr, Facebook. This is the old Facebook logo. Snapchat, very bad images. We have cameras everywhere. We have YouTube. Now we have like VR and stuff like this. So we have like tons and tons of images that are being captured and saved every day. And they need to be processed, right, in one way or another. We also have a huge number of useful applications. We will see all of these applications very soon. And definitely there's a large amount of these applications that can influence your daily life. Starting from your cell phone, which is using a lot of computer vision just to do basic tests. So just to see some computer vision in action, I'm sure you guys already know digit classification. So this is a digit recognition AT&T Labs from the 1980s. So you can see this is Linet 5. And what they do is they take a handwritten image, a digit, and they predict its class. So you can see that this performance for the 1990s was already tremendous, right? Huge improvement. Now let's move a bit forward. And now we are working with our cell phones using Google Lens. So honestly, Google Lens, I use it almost every single hour of every single day. A lot of capabilities that you can use from this app. Some of the main important things are like translation. So basically you are like using your phone and you just open the camera and it translates everything you see into the language that you're interested in. If you're looking at some like painting and you would like to understand the story behind this painting, just like open your camera, show us the painting, it will give you the story. It will give you, if you're looking, for example, at a building, if you're trying to, I don't know, if you see something like a dress that your friend is wearing, you take a picture and it will find you that dress online, basically, right? Give you even a comparison between different websites. So it's always very useful. And another very useful thing is it extracts phone numbers. So if like you're working with a friend and like they give you a phone number or email address, you no longer have to type it manually. You can just like take a picture and from the pixels of that picture, you will be extracting a text. So this is what some of the capabilities of Google Lens, but it does a lot more than that. And it can show you pictures of cute corgis. So that's good. Another application, so it's something in special effects of video, movies. So most of the, or like, let's say the majority of the movies that we are watching are built like this. So basically, there are no apes in Dawn Planet of, like that Planet of the Apes kind of a movie, sadly. So the actors are human beings, and later on, their images are being processed and converted into what you guys are seeing here, right? So they have some points on the suit, and the points of the suit map to some points on this like ape, and then they just do some calculations and some mappings between the two images, and voila, you have a very cool movie. Another cool application definitely is, for example, Amazon Prime Air. So it's just like delivering your products with a drone. You guys in Innopolis are already working with like self-driving cars. You also have that thingy, the thingy that gives orders. I wasn't there when it was created, so it's quite recent, but I hear that it's pretty useful. So now you can order food from anywhere inside Innopolis, and it will bring you the food all the way to your house. So definitely we're like taking jobs from those guys who do delivery and giving it to robots, right? So all of that is made by computer vision. It looks at like the environment and decides how to go or how to walk in order to get to your house. Another one was NASA's Mars Curiosity rover. So of course, it doesn't really have a specific path that it needs to take, and it has no idea how this path looks like. So you don't have like the whole map of the system, unlike for Amazon Prime or that Yandex thing. So it's trying to basically explore using some metric that is calculated using curiosity, right? And many research is being done on reinforcement learning that is rewarded using a curiosity instead of a predefined reward function. For those who don't know what reinforcement learning is, so reinforcement learning is just playing a game. So you're trying to build a model, computer vision model or a deep learning model that can play a game. This game can be a game in reality or like some real life scenario such as driving. It could be considered as just playing GTA, right? And instead of saying like predefining a reward function, you could use this concept of curiosity and other heuristics as a general reward that will work in any environment that the model will encounter. Another one was, well, fingerprint scanners. So I don't assume that any of you guys still use passwords for unlocking your mobile. So either you use fingerprint scanners, or you're going to be using facial detection software. This facial detection software can be using only camera. And for example, in iPhones, they use some infrared detectors or sensors. So definitely there's a combination of normal images that you see like this, plus a certain image in a different, let's say, pattern that allows you to get these, well, to fuse basically these two sensors in order to give more optimal performances. So another application, which is very important, this is something that you guys will be building by the end of this course. If we don't make it by the end of this course, definitely for those who are taking advanced computer vision, you're going to have to build a lot of models similar to this one. So for example, here is something from a computer vision model that is working on a self-driving car. So you can see it's able to detect the different lanes in the image. It's able to detect different cars. It's able to extract information about the scene. So we say time, it's daytime, weather is clear, the scape is city streets. So we can understand like the environment, basic classification here. And then we will have basic object detection. So we understand where each object is. So we understand where the cars inside the image is, and then later on map it to where the car inside the real world is. And of course, understand where is our lane and which will allow us to drive more safely. Same thing here. So as you can see, we're detecting cars, detecting different lanes. In this case, we're not just detecting cars as a rectangle, but we're detecting every pixel in the image. So these are like two different applications. They use two different architectures, but they're quite similar. So here, for example, we see this human being, another human being, another human being, and they're all being detected very, very clearly. Another application, sorry. Yeah, another application is image imputing. So for example, if for some reason you cannot access the full image or your sensors are a bit broken, you can impute this image or improve its quality using computer vision models. So you can see that this image was given to a model and the model reconstructed this image on the right. Obviously, if you don't look very closely, it looks okay. But if you do look closely, there are some problems here. So for example, this, what is this called? Like this barrier is not being mapped here. So there's definitely a lack of understanding of the environment, but it still looks like it belongs here, right? Like it belongs to this rest of the image, right? So it continued this, what is this called? Do you guys know what this thing is called?
Pillar.
Like, yeah, it continued this pillar quite perfectly until it arrived to the roof, and it's trying to like map this whole area together and link it together. Very impressive. Also, same thing in here. So it's building different windows. It has reconstructed the store, what is it called? Interface or like front, and even like try to match the words or the style of writing with the rest of the image. Very impressive. Another one was artistic drawings. So here you can see that these are images created by artificial intelligence models or by computer vision models. I don't know, I'm not a very artistic person, but they kind of look pleasing, like could be useful for like backgrounds and stuff, if you are into this kind of stuff. And the last part is super pixeling. So basically here we have the original artwork. What we feed into the model is a much more, let's say, reduced version of this one. So we try to map every, let's say, 8 pixels into just 1 pixel, right? So it's going to be a very pixelated image. And we try to improve its, what is it called? Dimensionality? No, it's clarity or beauty. Sorry, my English is kind of disappearing since I'm speaking French mostly. But yeah, you can see that this was one like baseline, which is the bicubic baseline. It's giving very bad results, although it's an improvement over its input, but it's very bad. So this was SRR ResNet, and we can see that already we have a little bit better. And here we are using something that is GAN-based, and definitely the results are very similar to the original artwork. Again, this is not the input of the model. The input of the model is something that is a lot more pixelated. So you see just like a lot of squares everywhere instead of smooth pixels like this. Do you guys have any questions so far? Mm-hmm. Anything? No questions. One second. So let's finish the presentation. Sorry. So now we're going to be basing on the lecture slides of Professor Fahim, as we said. Some of the difficult problems that you can face from for computer vision is the viewpoint variation. So here you can definitely see that it's a similar car, but it's seen from different viewpoints. And that's pretty difficult, for example, to compare pixel by pixel, something that is working like this. So basically, if statement that picture compares pixels is not going to be working in these scenarios. Illumination, so basically the lights, the background and the clutter. So for example, here in this case, the color of the background is very similar to the color of the animal, making it a little bit harder for humans and computer vision models to interpret. Interclass variations, so you can see that these are different models of like Ferrari, I assume, and they're quite very different from each other. So a model that is used to detect cars will have some difficulty working with this. Moving objects which are moving, they provide a significant challenge for the for cameras. Mainly since the camera is basically taking these pixels like sequentially. So the pixels are not taken instantly for the whole scene, but usually they're taken for like sequentially from the top down or bottom up. And occlusion, so basically the object is hidden in the background. So the human vision system, our aim is to basically duplicate this human vision system, but it's very difficult, mainly because we don't understand how it works. So we understand how the eye works, but not how the human brain interprets the signals from the eye. So this is what human eye looks like. I'm sure you guys have at least one of these. And it contains like three main components. So we have the cornea, which is a tough and transparent tissue. We have this choroid, which is a membrane, contains a network of blood vessels and major source of nutrition. And we have the retina, which is like the important part. What's basically happening around here? We have something that is sensitive to light, right? And we have like some sort of a lens that looks or that inputs light from outside of the eye and maps it on this wall. This wall is later like it's a pretty sensitive wall for light, and it tries to understand the images, the colors of these of the light and stuff like that. So we have like two main, let's say, cells inside this retina. So we have the cones, which are located near the center of the retina. They're highly sensitive to color, so you can easily interpret color using these things, and they can resolve fine details when you are focusing. So this is like these are the things that you use to focus on specific text or to read stuff. And there are these rods, which are kind of responsible for the dim light vision. So again, this is what's happening. This is a lens. We input the colors of outside or the light from outside into this interior wall, and the cones will interpret the lights, the colors. These guys will interpret stuff in dim light. Blind spots are just another around the region of emergence of the optic nerve. There is no receptors, so there are like those images where if you cover, like for example, the white spot, your brain kind of assumes that the whole image is red. You will find those on Instagram, and they're working on the blind spot of the human eyes. Basically, your brain is kind of fooling you and telling you that you are seeing all the image or all your surroundings, but in fact, you are seeing just like parts of the image, and you are doing that imputing inside your brain, right? Let's go a little bit. Yeah, so this is what's basically happening inside the eye. This is an object. It sends light. Light
happens to cross your eyes because you're looking at the object, and it's being mapped in the basically opposite direction, or being drawn, let's say, on the opposite direction inside your eye. We're doing something very similar to this one in cameras, like this. So this is what we are seeing, and basically the human brain interprets the signal as it is, as it's seeing it in reality. So there are lots of optical illusions. So for example, one very common one is assuming that this line is longer than this line, which is in fact wrong. Both of them have the same height. Another very weird thing, apparently this B, or the background of this B, is exactly the same as the background of this A. But since we are doing this shadow, the human eye is interpreting it as a lighter image. Pretty weird. Another very weird concept, which is this thing. So whatever you shift your focus onto these points, they become white and the others become gray. Sorcery. It's a static image and it's working like this. Another one is to how counting basically these red X's. Here it's pretty easy. Here it becomes very difficult. Yeah, image sensing and acquisition. Images are generated by a combination of an illumination source and the reflection or absorption of energy from that source. So as we said, we have a scene. This scene is basically sending out light. This light usually comes from the sun, or like your what is it called, a light bulb, and the light that is reflected from this object and goes to your eye. That's what you are seeing. How can we represent this concept of seeing in a computer? Remember, what we are seeing is just like a drawing, or let's say it's a value in a wall, right? So basically the inside of our eye is just a wall that is sensitive to light. So basically inside this wall you have different cells, and these cells will have different activation depending on the light that came in. This was kind of mapped directly into how images are being stored. So we have like a wall. Like in this wall there are different cells, and according to the content of this of the object in that cell, we will have a different activation or a different value. 0 means there was no activation or something is black, and 225 means that there was an activation and something is completely white. We're gonna go a little bit faster on this, and hopefully on the next lecture we will go through them again, okay? So this is what an image looks like, and this is how the same image would be represented in a computer. We have the sampling rate. Let's call it like the quality of your camera, right? So this is high quality, very like lower quality, a lower quality, and a very, very low quality. This is what you get from an Android. This is what you get from an iPhone. We have the digitization of an image. So we have the quantization concept. So here you can see every pixel inside this image is represented using 8 bits, making it a very clear image. Here we are representing every part of it with 2 bits, meaning, for example, you cannot really distinguish different colors from each other. And this is what quantization is. We will not be speaking about sampling rate. So this is something for people who are playing around with cameras and into photography. It's pretty interesting. It has some couple of theorems, but they're quite useless for our course. How do we represent images? So the pixel content depends on the image type. So there are grade level images. So there are color images. There are range images with depth information. There are medical images, for example, radiation absorbance levels. So there are MRIs, which are like 3D images. And there are, of course, X-rays, which are just like 2D images. And we have thermal images, which interpret heat, right? So here we have black and white, just basic binary representation. Here we can have something a bit more which is black ranging all the way to white. And here we have different shades of gray. This is represented on 1 bit. This is represented on 8 bits. Going a step further, we can represent images as colored images. I know you guys are surprised right now. And this was like the theorem of Isaac Newton, which says that white light, when it goes through this optical prism, or like, for example, just water, it gives you this, what is this called? Rainbow. Yeah, it just gives you the spectrum of colors. And from this spectrum of colors, they built the numbering of these colors. So for example, when you say, yes, so this range is what gives you another or a very important concept we will see later on how do we represent colored images. So you can say that this number, you can call this number 0 for what is this color? Purple or something like that. And then you go number 50 goes for blue, 60 is for green, yellow is like 100, and so on and so forth, right? Yeah, I think this is good so far. We can stop right now, and we will finish this lecture on the next week or the next session. After that, we will have our first quiz on next Monday. So try to be present on the first 5 minutes of the Monday lecture. So on the next lecture, we will have a little bit about the basics of computer vision as we did right now. And then we will have something a bit more advanced. So in this lecture, as I said, there's not much that you guys will learn, but hopefully on the next few lectures, you will be benefiting a bit more. So do you guys have any questions about the content so far? Are you surprised that there are grayscale and colored images, or is this common knowledge for you?
I'm only surprised with your hating Android camera resolution.
Ah, nice. Anyone else surprised about something? Amazon Go is not surprised?
I have a question.
Yes, go ahead.
Do we need to prepare anything or install anything before tomorrow's lab?
Not really, not really. Just come as you guys are. You can, like, if you guys have internet, you can quickly install everything. You're right. We're going to be using just some basic Python libraries. So just come as you are, have a laptop with you, prepare as you would for a normal machine learning course.
Okay, thanks.
You're welcome. If you guys don't have any more questions, we can call.
I have several organizational questions.
Yeah, go ahead, go
ahead. Will tomorrow labs will be offline or online? Or
that's a very good question. You should ask Karam. I think it's going to be it's going to be offline. So basically, you will have to go to the university. Please ask your TA about these things. So till now, as I said, the course was a bit of a surprise to me. So I still haven't even met the TA yet. Hopefully, I will meet him like right after this lecture. And yeah. If you have any questions about the lab, please ask him. He already has the content, and hopefully tomorrow you will have a good time with him.
And now further lectures will be like offline too, or online too, like this one.
Yeah, all the lectures will be online since I'm not in Russia. And yes, so feel free to stay at home and watch the lectures from your bed if you want.
And one more question for final project or maybe some homeworks, if we will choose some difficult task to train, are there any resources from universities that we can use, or we are on ourselves for this?
Very good question. I think you guys are on your own. So using Colab, you can definitely train anything you guys want, right? So if it's not going to be something Amazon scale, yeah, you can do it on Colab. There's no need to use the resources of the university. They're quite
like Colab is very, how can I say this, unstable because there is a lot of traffic on this. Like it is very hard to train anything. Like you train anything more difficult than transfer learning, it constantly crashes.
Sadly, I cannot really offer any of these things since I am not really officially a university professor or working with any labs. So this makes it a bit difficult for me to interfere in these things. But if you have a supervisor already in Innopolis University, he should have access to some computational powers, and he can share some with you guys.
Okay.
Nice. Thanks a lot for your question.
Thank you.
If you guys don't have any other questions, feel free to exit. For those who have questions, you can stay and ask as much as you want. Well, see you guys.
I had a question about the project. So should we firstly approve the project with you and stuff?
Exactly. Yep. So basically, I think in 2 weeks or 3 weeks, we will have a small session. You guys will tell me what the idea of your project is.
Okay.
I will tell you if this project is hard, if it's easy, if it's medium, and depending on this criteria, I'm gonna have different expectations, right? So if the project is too hard and you don't make it fully, you can still get an A. If the project is very easy and you don't make it fully, you're definitely getting a D.
Okay, thanks.
Yeah, you're welcome.
Yeah, about project, I was thinking for making a PR for PyTorch, some framework of PyTorch. Maybe you heard PyTorch Lightning. I wanted to implement an efficient DAT. How about that?
That's a very good task. Yeah.
Okay.
Yeah, that's true. Anybody who has any questions, please feel free to ask, or you can send me the questions on Telegram. For those who don't, feel free to exit. Thank you guys for your assistance, and see you in 2 days or 3 days.
Thank you. Goodbye.
See you.
Bye, bye.
Bye, bye, bro. Na, na, na.